Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X researcher and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Planetary Formation, Comets to Planets. Now, the standard theory on comets is that they are mainly made out of ice and that their tails are due to ice sublimating. And according to the theory, when the comet comes close enough to the sun, solar radiation hits the surface of the comet, thus heating the ice sufficiently for it to sublimate, that is, turn into water vapor. As a result, there should be multiple jets of water vapor issuing from the comet nucleus as it moves in towards the sun. However, as James McCanney describes in his book Planet X, Comets and Earth Changes, when the Giotto spacecraft was sent to Comet Halley in 1986, it found the comet nucleus immersed in a thick cloud which made up the coma. And the cloud was so thick that no sunlight could penetrate it. The only light came from the actual comet nucleus. In other words, the comet nucleus was emitting light. In addition, it's not possible for sunlight to hit a surface in order to cause ice to sublimate if the surface is enveloped in a cloud so dense that sunlight cannot penetrate it. And here we see an image of Comet Halley as it made its passage through the inner solar system in 1986. And comets inside the solar system develop a tail and a thick cloud around the nucleus, which is actually a piece of rock, as you can see here. It's a thick, dense cloud around the nucleus of the comet. Now, according to the standard view, the comet nucleus should have been mainly white, but what was seen through Giotto's camera was that the nucleus of the comet was a dark, pitted, and burned piece of rock. There was no ice to be seen on the surface at all. In addition, as the spacecraft approached the nucleus, it was hit by an electron beam, which it was not designed to withstand, as the designers did not imagine that any such electrical effects were possible. Now, after realizing that Comet Halley's nucleus was dark, the theory regarding comets was changed to say that the ice was under the surface in deep pits, but the solar radiation will still hit the surface sufficiently to cause the ice to sublimate. However, the fact that so little solar radiation gets through the dense coma cloud that the nucleus would be impossible to see except for the fact that it was emitting light makes this idea absolutely ridiculous. A few years later, in September of 2001, NASA's Deep Space One spacecraft photographed the nucleus of Comet Borrelli. At the time, the comet had a full tail, but the nucleus was not ejecting any water at all. With such a well-developed tail, the comet should have been sublimating a huge amount of ice into water vapor, and therefore the nucleus should have had numerous jets of water vapor. But there was nothing, which indicated that the tail could not be coming from ice inside the comet nucleus. This shows that comets do not have any ice on them. They are rocks and therefore just like asteroids. And we see here a composite image of Comet Borrelli's nucleus from NASA's Deep Space One spacecraft, and there was absolutely no jets issuing from the nucleus of the comet. In 1994, Comet Schumacher-Levy 9, which had earlier broken into pieces, impacted Jupiter. Now, if the pieces had been made of mainly ice, they should have buried themselves into Jupiter with nothing left to show for the impact. But instead, the impact was so explosive that the resulting X-rays and ultraviolet light reflecting off Jupiter's moons could be seen from Earth. In addition, the cometary pieces all had water tails, but the moment they approached Jupiter, the tails became entirely composed of sodium dioxide, and the water completely disappeared from the tail. How is this possible? This actually indicates that comets derive their tail material from their local environment, and that the environment around Jupiter is different from anywhere else in the solar system. And we see here the different pieces making that comet Schumacher-Levy 9 broke into. They all had their own tails and their own comets. And here we see an ultraviolet image of Jupiter after the impact of the 7 pieces, and these huge blemishes were left on Jupiter, indicating that these comet pieces could not possibly have been made out of ice. There is no way that little pieces of ice could cause such huge explosions and such damage to Jupiter's atmosphere. Jupiter must in fact be a small star, as it produces a lot of heat and radiation that cannot be coming from the sun. This means that it must be fusing light nuclei into heavier nuclei in its atmosphere. The nuclear fusion is enabled by electric discharges in its atmosphere in the same way as in the sun. So Jupiter, just like the sun, as detailed in article 168, electrical sun in toroidal envelopes, ejects positive ions, atoms with electrons missing, which leave the atom with an excess of positive charge due to the positive charge on the protons in the nucleus. Now, so the sun and therefore Jupiter seem to be retaining electrons whilst ejecting these positive ions, and thus creating a cloud of ions around it. This cloud must have been where the sulfur came from for the Schumacher-Levy 9 comet pieces. This therefore suggests that Jupiter forms a capacitor around itself in the same way as the Sun, but Jupiter's capacitor is much smaller than the one formed by the Sun, and this is illustrated below. So we have the Sun, which forms in the Sun's inner corona, which is has more electrons than positive ions. We have the negative capacitor plate, and then we have the Sun's nebula ion cloud, which is made up of positive material, positive ions, and dust that is positively charged, and this then is the positive plate of this capacitor. And then Jupiter forms its own capacitor within the solar system. So here is Jupiter. At Jupiter's atmosphere will be the negative plate, and Jupiter's positive plate is outside that where Jupiter's nebula ion cloud forms. So what happened was, as the comet pieces came in towards Jupiter, whilst they had gone around the sun already. So as they came towards Jupiter, whilst they were still inside the solar system, they were getting hydrogen and oxygen coming into the tail. So from this side of the sun, or from therefore from the nearest nebula cloud. It may not have been the one outside, it may have been one nearer to the sun, but as they got closer to Jupiter, they still had hydrogen and oxygen in their tails. And the hydrogen and the oxygen would then combine at the nucleus as the electron current would interact with the hydrogen and the oxygen coming from the nebula cloud, thus forming water. But as soon as the comet pieces crossed into Jupiter's capacitor, or went through nebula's ion cloud, they started drawing in sulfur instead of hydrogen. So instead of forming water at the nucleus, the comet started forming sulfur dioxide at the nucleus. And this possibly suggests that Jupiter may be fusing sulfur instead of hydrogen. The sun is obviously still has lots of hydrogen, so it fuses hydrogen into helium. But it seems that possibly Jupiter has run out of hydrogen and may be fusing sulfur instead of hydrogen, which is why it then ejects sulfur ions, and its cloud is then mainly made out of sulfur. and then the sulfur would combine with the oxygen. Now, since fusion is enabled by electric discharges, fusion of any element is possible, although less initial energy would be required to fuse lighter elements, and the lightest of which is hydrogen. So the fact that the star is fusing heavier nuclei may mean that it has run out of the lighter nuclei to fuse. Now, any man-made object which goes into orbit, or in other words, goes outside of the Earth's atmosphere, becomes negatively charged. This was discovered with the space shuttle, which quickly became negatively charged and then started capturing oxygen ions, which resulted in faint light being given off from the outside of the space vehicle. As the oxygen ions recombine to form oxygen, then photons are given off, so light is emitted. This is most likely because the object will have some internal potential, which causes the charges it is made of to separate in the space environment. Inside the Earth's atmosphere, it would be electrically connected to Earth and thus be a part of the Earth's overall potential. And so its charge distribution would become a part of the whole planet's charge distribution. The planet itself would then produce an electron layer at the edge of its atmosphere according to its overall potential, which should be related to its position within the solar capacitor. So what we see here is that any object in outer space, according to its potential, will take some of the electrons that are part of the matter inside it and move it to the outside so that it forms a layer of negative electrons around the object, so that there is a potential between the inside and the outside, which coincides with the object's own potential, and therefore it's due to its origin. It's the object from which it originates. So, for example, the space shuttle originated inside Earth, so it would have the same potential as Earth, and according to its position in the solar system relative to the sun as well. So a free object in outer space, be it a planet, a star, or a man-made object, will separate its charge according to its inner electric potential. In other words, enough electrons flow to the outer surface of the object for the potential between the center of the object and its outside surface to reflect the object's potential. This means that any rock entering the solar system, and therefore the solar capacitor, will already be negatively charged according to its own potential. But as it enters the solar system, it encounters an environment with a different potential. This difference causes charge to flow from the environment to the rock in order to try to equalize its potential to its environment's potential. This causes both negative and positive charges to flow toward the object. So this is what we see here. We see a comet. It would already have some potential outside the solar system, but as long as that potential is lower than the potential for each equipotential surface around the sun, then the moment it comes in, then the environment will supply a current towards the object in order to try and increase its potential to equalize it to that of the environment. So as the comet comes in, a current starts flowing. Let's say for the comet here, an electron current flows from the environment, and it will be extended backwards until it ends at the sun, and the current from the nearest nebula cloud of ions will flow towards the object in the opposite direction. So this is a positive current towards the object. This is a negative current towards the object. This one is of electrons. And so this current will try to equalize the object's potential, but the object is moving in fast towards the sun and therefore crossing many equipotential lines. So as it crosses equipotential lines, its potential has to increase because in terms of negative or it has to change accordingly to the sun's own potential. So the environment keeps trying to equalize the potential as the object crosses equipotential lines and goes around the sun, and thus there will be a current flowing in towards the object from the outside and another one from inside from the sun. Now the flow of charge will be perpendicular to the surfaces of equipotential, or surface where the potential is the same at every point on it. So if we see these are equipotential surfaces, so the potential along each surface, and they will be circular, actually they are toroidal, and they have a certain height, but so basically they have cylindrical symmetry, and these so the potential is the same all along each surface. So as the object crosses each surface, it crosses over from one potential to another. So as charge close to the object starts to flow, charge behind it flows to fill the space left empty until the charge extends all the way back to the source. The source of the negative current of charge inside the solar capacitor is the negative plate of the solar capacitor, or the sun's inner corona. So if we have a comet here, this current, the electron current, comes from the sun's corona, where we have an excess of electrons. And the positive current comes from the positive plate of the capacitor, or the nearest nebular ion cloud. So here we see the positive current, and this is what forms the tail on the comet. And there's an electron current, which is not actually visible unless it's a very large and very fast moving comet. And so it's often not visible until you get right up to the comet. But this one, the tail is visible as it comes towards the comet, comes in towards the comet. And then there is the coma, which is a dense cloud formed from elements combining as electrons and ions from both currents interact. And so the comet is, because it's following an elliptical orbit, it moves through different surfaces of equipotential. And so the current continues to flow in an effort to equalize the comet's potential with its environment. Now the electron and ion current meet at the comet and interact, leading to the formation of new compounds. Hydrogen and oxygen combine to form water. Sulfur and oxygen combine to form sulfur dioxide. Carbon and hydrogen combine to form hydrocarbons or oil. And in the process, a lot of energy in the form of heat is released. In the ion current, there will be positively charged dust as well. In a small comet, most of the recombined gases flow back into space because they're now neutral. And as the comet does not have a large enough gravitational field to retain most of these elements, but it will still be able to retain some dust and some heavy elements. But if the comet is large enough, its larger gravitational field will allow it to retain the lighter gases as well. So water and oxygen, molecular oxygen, and so on. Now, the combination of hydrogen and oxygen to form water releases a lot of heat. Also, some of the particle impacts occurring on the nucleus of large comets is so energetic that fission reactions occur and unstable or radioactive elements are produced. The impacts themselves release a lot of heat, but the radioactive compounds will also continue to release heat for millions of years as they continue to decay. In larger comets, the heat can get so intense that the nucleus melts, at which time it self-gravitates. In other words, it turns into a spherical object in response to the spherical symmetry of its own gravitational field. In addition, the positive ion tail pulls back on the comet and causes it to slow down. This has the effect of reducing its orbit. Comet Hale-Bopp's orbit went from an orbital period of 4,200 years to 2,650 years when it made its trip through the solar system in the late 1990s. This means that each time a comet goes through the solar system, its orbit becomes more circular until eventually it becomes a captured planet or moon. So here we have illustrated what actually happens as comets are captured and become a planet or moon inside a star system. So we have the initial rock, which may be in any shape. As it passes or it makes its first passages through the star system, it collects some heavy elements, some dust on the surface, and then eventually it gets large enough so that with one passage it melts, and so it becomes spherical with whatever object it's collected making up part of it. Then it continues to collect more layers each time, but it continues to be spherical because each time there will be some melting of the outer surface, and so it continues to grow, and eventually it's massive enough to start retaining lighter elements. And then eventually, and as its orbit also becomes more and more circular, eventually it stays within the bounds of the star. Its orbit is more circular, so it becomes either one of the planets in that solar system, or it may be captured as a moon by one of the other planets. And in that case, it will most likely start out completely melted, and then it will cool down so that it will form a crust, but it will still have a very hot surface inside it. It has radioactive elements. It will continue to produce heat on the inside. It will thus still have a liquid layer on the inside, and it will retain gases and thus have an atmosphere. And at this point it will be a very hot young planet, just like Venus is at the moment. And this suggests that planetary systems do not form in one event, for instance 4.5 million years ago, where they all formed together, but rather planets and moons are captured throughout the lifetime of the solar system. In addition, planets are formed out of small rocky fragments or asteroids. These asteroids may start out as small rocks, and in their initial passages through a solar system will only gain dust and heavy elements like iron, but it grows each time. It makes its passage through the inner part of the solar system, and each time it passes it gains more material drawn in by the comet tail. The tail forms as the comet discharges the star capacitor, and therefore the star itself is the source of all the outer layers of the planetary objects which it forms and captures. Eventually the comet becomes large enough to produce enough heat to melt and turns into a spherical object. The coma around this nucleus will stop flowing back out into space and remain around the object as it goes back out and away from the star at the center. And eventually these captured gases become the atmosphere of the developing planet. Each time it passes the orbit, becomes more circular until it settles down into an orbit which is very close to circular. It will continue to discharge the capacitor though for a long time, as most planets, including Earth, still have an ion tail, which most astronomers interpret as a magnetic tail. The new planet will at first be extremely hot, but over time it will cool down, and the water in its atmosphere will eventually condense into oceans. The planet will remain active because the radioactive compounds produced in the nucleus of the comet, which will now be the core of the planet, will continue continue to release heat as they continue to decay. And thus the planet will continue to have molten material inside it for a very long time. And here we see Venus. We can see that it has an extremely dense atmosphere. A lot of its atmosphere is too hot to have condensed into liquids. It has an extremely high pressure. The temperature on the surface is 864 degrees Fahrenheit or 462 degrees C. So it's still extremely hot, and this is what it looks like without the clouds. There's a lot of volcanic activity, a lot of volcanoes erupting. Obviously, it's a very volcanically active planet still, as we would expect a young planet that has not so long ago been captured by the sun, how we would expect it to be. It's still a very young and hot planet. Venus, with therefore its extremely hot atmosphere and volcanically extremely hot interior, is therefore the most likely newest addition to our solar system. It still retains its positive ion tail, which most planets, including the Earth, also do, indicating that the current planets in the solar system are still discharging the solar capacitor, although weakly, not nearly as strongly as comets do. This means that it must take a very long time for planets to be completely acclimatized to the correct potential of their environment in the solar system. In conclusion, comet observations reveal that they are not dirty snowballs, but rather protoplanets. Comets become captured planets or moons in star systems. Each time these comets pass through the inner part of a solar system, they grow in size and their orbit becomes more circular until eventually they become a full-fledged planet with heavier elements it captured in its first few passages deep in its interior, and the lightest elements it captured in its later passages, forming its atmosphere. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.